Hello, we're Team B14 and for Hack 8 we'll be showing you our proposed solution for Challenge 9, Learning from Programme Updates, and sponsored by MPlan. To begin with, we've formed two user stories. The first is a project planner who would like to understand which activities in the programme are the most erratic, i.e. where are the problems. The second as a scheme project manager who'd like to understand which features are likely to cause variation and slippage, i.e. what is causing the problems. To solve these, we've created a predictive model which identifies features of activities which have the most negative outcome on the programme, alongside a suite of Power BI dashboards to visualise our findings. From reviewing the P6 data provided by the A14 project, we found the quality to be fairly high, with some inconsistencies found around the dates and the activity definitions and coding. This was corrected by cleaning. We've tried to develop a plug-and-play model which any project using P6 software could easily add their data to. Assumptions we have made during the weekend. There was no baseline changes prior to the first extract date, which was September 18, and our model follows a linear trend with the variance due to time constraints. Here's some of the tools, packages, and data sources we have used.
High-level indicators looking back on historic performance, and then we've got one here which is coming out of the predictive side. So again, as we start to walk through the story of the data, just bear in mind the planner and the project manager. So if we have a look down here, so we want to dive into the 1,200 activities that relate on section 4. So again, we can just walk down through the story of the data and drill through. So here we land, and we've got the high-level insights into the key drivers of program slippage for section 4. So we've got the top 5 activities that really did slip in the program. And then next to it, we've got the locations where you'd really want to focus your efforts on, and just to see if you can stabilize the program there. And then the table down below would just then allow the next level down in the detail. So this is taking those high level summaries, we step it down one level, give you the key insights and indicators, and then allow you to step down again. So taking you through the story of the data. I'm not going to take you down specifically into those two, just for purely full of time, but I'm going to show you what those would look like if you just unfiltered it. And if you unfiltered it, this really then gives you just a nice overview analytics tool to say, actually, let's just have a look across the program. Let me just really understand where I've got slippages historically, with a view to having a look at those activities and focusing on them in the future. So again, just rags, this is the variance one. We've got one for baseline changes as well. And then you can just step down and you can have a look and see what's actually driving those. And again, you can step down and again. So this is really being able to show that link down through the levels and making sure there's nice clear messages as you go down to supplement the traditional scheduling metrics.
Prediction tab is a scenario builder to estimate future performance based off historic performance. The user is able to slice data by WBS and location to estimate slippage of a future activity based off previous performance of similar activities. There's a comparison between the estimates provided from a standard P6 data review and the machine learning model developed within Python, which accounts for significant features. An example scenario for section 6 pavements is the P6 estimate to complete on time is 64%, whereas the machine learning prediction will estimate this closer to 100% based on the overall confidence in the program. The Early Indicators tab is an output from the machine learning model developed within Python to present significant factors contributing to activity slippage. When considering early warning indicators, initial analysis indicates the month and timing within the year as the key indicators to poor performance against the baseline, as well as sectors 2, 3, and 4 generally experience poor performance historically.
We've included a predictive model within the dashboard to allow the management team to take proactive actions to mitigate issues rather than just react to project slips. To define this model, we followed the standard machine learning model development phases, where initially we identified and removed issues and anomalies from within the dataset provided, before defining the key features to be used within the model, leveraging the domain knowledge from within the team to allow us to focus on those key features. These were then converted to be suitable formats to be used within the model. The model itself is a gradient boost regressor from scikit-learn. The current model actually means it's not suitable to be used directly, but does form a solid basis for future development.
We've been able to review a broad range of features based on the data, but have only scratched the surface of what may be causing program issues. The next step would be to look at further sets of planning, internal and external data. Our team have already undertaken, for example, some initial analysis linking open source Met Office weather data to program variance, and think that this would be worth exploring further. In terms of the model, what we have created could be further refined through an iterative process of adding, cleaning and refining data to move towards higher accuracy, higher granularity and clearer conclusions.
The top 5 WBS groupings of activities that appear to be particularly unstable: accommodation works, electrical works, landscape and ecology, lighting and fencing, are shown in the chart labelled median number of days slipped by WBS series. These groups have significant variances between actual finish date and baseline finish date. The higher the number, the higher the average slippage. We have also presented this data by location to provide insight into whether particular locations had trends of instability within the programme. The Early Indicators tab is an output from the machine learning model developed within Python to present significant factors contributing to activity slippage. When considering early warning indicators, initial analysis indicates the month and timing within the year as the key indicators to poor performance against the baseline, as well as sectors 2, 3 and 4 generally experience poor performance historically. For future development, this will require more investigation to provide better insights for the user when estimating potential performance at the activity, WBS and sector levels.